So good morning, sir. Now today we discuss about numerical methods and the topic name is numerical integration. In numerical integrations, we know that integration of a to b f of x dx can be evaluated if there exists a differential function capital F such that f dash of x is equal to f of x in a comma b. However, in applications, we come across integrals of the forms integral of a to b e to the power of minus x squared by 2 dx, which cannot be evaluated in the closed form or analytical form. Sometimes the f of x is given by the set of recorded values xi, f of xi for I is equal to 0, 1, 2, 3, so and so. In such cases, we use the method of numerical integration. Numerical integrations is the process of evaluating a definite integral of a to b f of x dx from a set of tabulated values in the integrated f of x, which is not known as complicated. This process is known as mechanical quadrature. Geometrically, integration of a to b f of x dx represents the area bounded by the curve y is equal to f of x and x axis between x is equal to a and x is equal to b. The various numerical integration formulae are given different approximation to this area. Now, trapezoidal rule. So, integration of a to b f of x dx is equal to h by 2 into the sum of the first and last ordinates plus 2 into sum of the remaining ordinates. That means integration of a to b f of x dx is equal to h by 2 into y naught plus yn plus 2 into y1 plus y2 plus so and so yn minus 1. Here h is equal to b minus a by n. That is b means upper integral, a means lower integral, n means number of intervals. Now divided, we know the Simpson 1 by 3rd rule means the integration of x naught to x naught plus nhf of x dx is equal to h by 3 into sum of the first and last ordinates plus 4 into sum of the odd ordinates plus 2 into sum of the even ordinates. That means integration of x naught to x naught plus nhf of x dx is equal to h by 3 into y naught plus yn plus 4 into y naught y1 plus y3 plus y5 plus so and so plus 2 into y2 plus y4 plus y6 plus so and so. Here also h is equal to b minus a by n, where n is equal to number of intervals. For example, dividing the range into 10 equal parts, find the approximate value of integration of 0 to pi f of x dx by using trapezoidal and Simpson 1 by 3rd rule. So solution, we know that the interval 0 comma pi in divided into 10 parts, that is n equal to small 10 and h is equal to b minus a by n, that is pi minus 0 by 10, that is pi by 10. We shall find the values of y is equal to sin x at the points of division, x naught equal to 0 and x1 equal to pi by 1 pi by 10, x2 is equal to 2 pi by 10, x3 is equal to 3 pi by 10, so and so. Now we have to use the calculator. Now x is equal to 0, 1 pi by 10, 2 pi by 10, 3 pi by 10, 4 pi by 10, so on so 10 pi by 10, that is fine. Now corresponding y is equal to sin x. Now substitute x is equal to 0, pi by 10, 2 pi by 10. Now we get the corresponding values. Now trapezoidal rule means integration of x naught to x naught plus nh y dx is equal to h by 2 into sum of the first and last ordinates plus 2 into sum of the remaining ordinates. That is, therefore we get the answer is pi by 10 into first value, sum of the first and last ordinates plus 2 into sum of the remaining ordinates. Now we have to substitute the value. Now we get is equal to 1.9835. Now we have to use the Simpson 1 by 3rd rule means again integration of x naught to x naught plus nh f of x dx is equal to h by 3 into sum of the first and last ordinates plus 4 into sum of the odd ordinates plus 2 into sum of the even ordinates. That means h by 3 into y naught plus yn plus 4 into y1 plus y3 plus y5 plus so and so. plus 2 into y2 plus y4 plus so and so. Now we get the substitute. Now substitute h by 3 into, we get the answers is pi is equal to 2.001 approximately. Now we have to actual integration. Integration of 0 to pi sin x dx is equal to cos minus cos x. Now substitute upper limit minus lower limit. We have to get the approximate values true, which is true value. This justifies the fact that Simpson formula is more accurate.